So this one has a video that we're supposed to watch.
Oops.
Do you want to play it? Will it play through Google Hangout? I don't know if it will.
I don't think so.
If I share my screen.
Let's see if it works.
Okay, let me share my screen. The question I'm wondering is if you'll be able to hear it.
Yeah, that's what I was going to say. Because I know with Zoom you can't, but...
Okay.
This is day 4, right? Yeah.
Yes.
I could try unplugging my headphones. Maybe you'll hear it like through the speakers if it's not.
Oh, right.
So right now my headphones are plugged in. Do you hear that?
No.
Okay. Let me try
when you say that the limit...
Yes.
There you go.
Okay. Let me start it over.
Oh, can't hear. Can you turn it up or?
Okay, let me try.
As close as you want by making X sufficiently close to C. So instead of saying as close as you want, let's call that some positive number epsilon. So I'm just going to use the Greek letter epsilon right over there. So it really turns into a game. So you tell me how close you want. So this is the game.
Can you plug the printer in real quick? I have it pulled out.
Close.
Couldn't hear you.
Sorry, guys. It wasn't me. My husband popped in.
Hey.
You want f of x to be to L, and you do this by giving me a positive number that we call epsilon, which is really how close you want it. You want f of x to be to L. So you give a positive number epsilon. And epsilon is how close do you want to be? How close? So for example, if epsilon is 0.01, that says that you want f of x to be within 0.01 of epsilon. And so what I then do is I say, well, okay, you've given me that epsilon. I'm going to find you. I will find you another number, find another positive number, another number, which we'll call delta, the lowercase delta, the Greek letter delta, such that, so I'll say where, if x is within delta of c, then f of x will be within epsilon of our limit. So let's see if these are really saying the same thing. In this yellow definition right over here, we said you can get f of x as close as you want to L by making x sufficiently close to C. This second definition, which I kind of made as a little bit more of a game, is doing the same thing. Someone is saying how close they want f of x to be to L, and the burden is then to find a delta, where as long as x is within delta of C, then f of x will be within epsilon of the limit. So that is doing it. It's saying, look, if we were constraining x in such a way that if x is in that range to C, then f of x will be as close as you want. So let's make this a little bit clearer by diagramming right over here. You show up and you say, well, I want f of x to be within epsilon of our limit. So this right over here, this point right over here is our limit plus epsilon, and this right over here might be our limit minus. This right over here is minus epsilon. And you say, okay, sure. I think I can get your f of x within this range of our limit, and I can do that by defining a range around C.
Yeah.
And I could visually look at this boundary, but I could even go narrower than boundary. I can go right over here. It says, okay, I meet your challenge. I will find another number, delta. So this right over here is C plus delta. This right over here is C minus write this down, is c minus delta. So I'll find you some delta so that if you take any x, in the range c minus delta to c plus delta, and maybe the function is not even defined at c, so we think of ones that maybe aren't c but are getting very close. If you find any x in that range, f of those x's are going to be as close as you want to your limit. They're going to be within the range L plus epsilon or L minus epsilon. So it's another way of saying this. Another way of saying this is you give me an epsilon, then I will find you a delta. So let me write this in a little bit more math notation. So I'll write the same exact statement with a little math here, but it's the exact same thing. So you give me, you give, or let me write it this way, given an epsilon greater than 0, we can find, so that's kind of the first part of the game, we can find a delta greater than 0 such that if x is within delta of c, so what's another way of saying that x is within delta of c? Well, one way you can say, well, what's the distance between x and c is going to be less than delta. This statement is true for any x that's within delta of c. The difference between the two is going to be less than delta. So that if you pick an x that is in this range between c minus delta and c plus delta, and these are the x's that satisfy that right over here, then, and I'll do this in a new color, then the distance between your f of x and your limit, and this is just the distance between the f of x and the limit, it's going to be less than epsilon. So all this is saying is if the limit truly does exist, it truly is L, is if you give me any positive number epsilon, it could be a super, super small one, we can find a delta. So we can define a range around C so that if we take any x value that is within delta of C, that's all this statement is saying, that the distance between x and C is less than delta. So it's within delta C. So that's these points right over here, that f of those x's, that the function evaluated at those x's is going to be within the range that you are specifying. It's going to be within epsilon of our limit. The f of x, the difference between f of x and your limit will be less than epsilon. Your f of x is going to sit someplace over there. So that's all the epsilon delta definition is telling us. In the next video, we will prove that a limit exists by using this definition of limits.
That guy's long-winded.
I
I turn my volume down. So I can again. Oh, excuse me for a large portion of that video because his symbol for epsilon doesn't look like the one on the.
True.
I guess I should stop sharing.
Yeah, his symbol looked like the backwards version of such that.
Woman
Yeah.
But whatever.
For a really long time, I thought he was referring to the such that.
Hmm.
And then I realized near the end that it was flipped. And
Gotcha.
And I was like, trying to confuse me.
Okay, so
It's
So
bad
the-
that I don't want to read this.
I don't either. So for question number 1 for notation exploration, it's just restating what it says, fill it in the blank. So the upside down A means for every,
Mm-hmm.
Epsilon greater than 0, there exists a delta greater than 0 such that f of x minus L is less than epsilon when 0 is less than absolute value of x minus a. That's it.
Oh my gosh, we have 2 activities.
Yeah, one of them is definitions, and the other one is proving it. Don't know if we really need to work on the definitions together. I mean, we can.
You know, I am not a big fan of long writing, so maybe these notations will actually be something I enjoy having at my disposal.
Yeah, my problem is just remembering them. I remember the basics, the E and the delta, if I can draw delta. It's like an S that's closed at the bottom. So do we want to work on the proofs? The second activity? Activity B.
You think we'll be able to understand it without doing activity A?
I mean, maybe.
Well, there's another video to watch, and I feel like doing that would have helped.
Write the words.
Adam, can you bring me a power cord, please?
And also, the homework for today is easier than the activity.
Oh, seriously?
Opposite. In all fairness, I didn't understand the activity at all. I was like, what?
You've already done the homework and the activity?
Yeah, because I have to take the test tomorrow.
Oh.
So I had to go ahead. Plus I have like a bazillion assignments in my other class that's due by Saturday. So but when I did the homework was actually made everything make sense. Although I still don't understand what they're trying to say in the activity. I actually only had to help me with this problem once or twice instead of.
Wow, that's impressive.
Yeah, because I usually have to do it for everyone.
Also, how are you guys studying for the test?
I haven't. Not yet. Which is silly because I'm taking it in 2 hours.
Oh my gosh, what?
I always have to take it on Thursday. It's when my proctor's available.
Right.
Yeah, I just I'm not quite sure because none of it's on limits. Like I looked at the study guide, like it's nothing that we've been looking
Yeah,
at.
I'm hoping limits don't show up.
So
they're not limits. She said she overslept. Are we going to switch it to today permanently?
what the frick?
Well, you can tell her we're just barely starting and she can come still.
Yeah.
Do we want to watch the other videos, Samantha?
I mean, I probably will if we don't all together, just because I need videos and stuff, especially when she's working something out on paper. It's just more helpful for me. But
What? Why are you soaking wet? Shy. I don't know if he has a change of clothes.
He has it. Hey, Mommy.
What?
Can you put on the iPad so we
No.
can be quiet?
No. Just be quiet. Let's see.
Can't play.
Oops, I'm on the wrong day.
Mommy, we can't play this.
You can play, just quiet.
So hard to be a kid.
You weren't outside long enough.
We'll be loud.
Okay, so
Okay, let's go back.
the video, it's only, oh my gosh, it's 7 minutes long. Hmm.
Mhm.
So should we watch it?
Okay. Anything good on the sound?
It says my teacher explained that we might understand completely, but we should study the ideas carefully and repeatedly, even if we don't understand them. Oh my.
Mommy, do I want to go back?
That's fine. I'm just watching.
Yeah. Can we have my
Lunch in a minute. We're gonna go see Uncle Matt.
We would like to prove
Quiet.
look at this graph, we can see that as x approaches 3 from the left and from the right, the y values are marching toward the y value of 5. And so it appears from the graph that yes, indeed, the limit of 2x minus 1 as x goes to 3 is 5. We would like to prove it. We said informally that the limit is equal to 5 because if we get really close to 3 from both sides, the y values get really close to 5 from both sides. But what does really close mean mathematically? Well, you learned some notation that will help us, and you saw some a proof by Sal Khan on Khan Academy that did a limit proof using epsilons and deltas. Let's just talk through it for a second. The proof says, given any epsilon, so you get to choose, well, you don't, but anybody gets to choose an epsilon. It can be as small as you want it to be. So let's say we say epsilon is this big. And an interval around 5. For any epsilon interval, if I can find a corresponding delta interval around the x value, in this case 3, I can find a corresponding delta for every epsilon, so that every x in the delta interval around 3 produces a y in the epsilon interval around 5. Then I say that that's what it means to be very close. No matter how close I get here, I can always find an interval around 3. So the first thing we need to do when we're writing this proof is to write down some words. For every epsilon greater than 0, there exists a delta greater than 0, such that the difference between the y values and the limit is less than epsilon, or equal to the difference between x and a is less than delta. Now this notation with the 0 less than or equal to just means that my interval doesn't need to contain the actual value, in this case 3. The center of that interval is part of the domain of the function. All right, so we learned some symbols so that we don't have to write things like for every and there exists and such that. For every epsilon greater than 0, there exists a delta greater than 0, such that our f of x in this case is 2x minus 1. This this statement needs to be in your proof. And I'm going to simplify this expression with epsilon, this epsilon interval. And rather than write 0 is less than every time, I'm just going to note that x does not equal 3. Okay. All right, we're considering this interval with 3 not in it. All right, what I want to do is, because this is a linear function, I can factor out a common factor. So I can factor out a 2. And I'm just going to write the whole sentence each time. The absolute value of 2 is 2, and then I'm going to solve because these absolute values are the same. So if I solve this one for the absolute value of x minus 3, this one is already the absolute value of x minus 3. Well, if both of these are the same and they're less than delta, epsilon over 2 or delta, then I can set delta equal to or even less than epsilon over 2. So I say, so let delta be less than or equal to epsilon over 2. In other words, set these two equal to each other or less than. So what does that mean? Well, no matter what epsilon you give me, if it's 0.01, if I take half of that and go 0.005 in this direction to the right of 3 and 0.005 to the left of 3, that delta interval will contain x's. Every x in that delta interval will produce a y that gets caught within 0.01 of 5. So to finish our proof, what we want to do is explain that. So if we let delta be less than or equal to epsilon over 2,
Yeah. Why did it?
Okay, so that's basically that's exactly what we have to do for the proof of limits. She just worked out. So you have to do all the problems like that.
That sounds totally silly. Oh. Oh.
So I guess we just work on that. The limits?
Yeah, the proofs. So we have to write that sentence. The upside down A, epsilon, greater than 0. What is E such that? I'm never going to remember this. Delta greater than 0. Does it make sense, Sam?
I gotta like, sorry, when I'm sick, my brain is like so, I can't hardly like focus. So
I understand.
So you have to write out like that flat paragraph she just like wrote out, basically?
Yeah.
Okay.
Now I'm like, what's X and A? And number 1.
So for the first
So
one, if I just look at the key, will it make sense?
it might. So, like for instance, for the limit 3x plus 1 equals 10,
Yeah.
you write out the that paragraph, and then in absolute value, put 3x plus 1 minus 10.
Okay, so it's minus 9.
Right. And then it's x minus 3 because you got x.
Pull the 3 out.
Yeah, because that's what you're trying to find. So, bless you.
Thank you.
So 0 is less than x minus 3 less than delta. So then you do the absolute value, you just combine it. So 1 minus 10 is 9, negative 9. So it'll be in the absolute value symbol, it'll be 3x minus 9.
Right.
Then you do less than the epsilon, when then x minus 3 is less than delta, and then x cannot equal 3 because it can't equal 0, right?
Where does the x minus 3 come from? Just plain old x minus 3.
I think
Yeah.
it's because it's 3x. Or no, because it's the limit as we approach x.
Yeah,
As we approach 3.
that's why it's x minus 3. So for
Lim x approaches.
Oh, so like that's why for like the second one it's x minus 1 because like it's x to 1.
Yeah.
yeah, so the number 2 is x minus 1 because
Number
it's x.
X minus 3. Okay, got it. Epsilon's on the y-axis, delta's on the x-axis. Right.
Mhm.
So you divided by, there's epsilon over 3 because they factored the 3 out, right?
Right. So then you have to divide it by 3 to get epsilon divided by 3.
So how is delta, why delta is less than or equal to epsilon over 3? Why wouldn't they be equal?
It's less
Oh, it
than.
has to be less than.
Yes.
So it lands in that interval. Got it. And then all we're doing is proving. We're really not doing like hardly any math, right?
Yeah, because we don't have any other numbers, so we're just proving that that's the case. That's the it exists, I guess.
Okay. And every x value would be just interval around 3 will produce value of the epsilon interval around 10. Therefore it is. Okay. Alright, I get it. It's fine.
Yeah, so the homework isn't, I mean, it's limited and all that, but you don't have to prove anything. You actually are solving the problems.
Okay. I'm gonna go with this.
You're finding the limit or delta for the homework. Now, this could be on a test. I'll be so good at drawing all these Greek letters by the time I'm done with this class. No. My husband's Greek, so.
My great grandfather is Greek.
That's awesome. Yeah. So his great grandfather immigrated here from Greece. And get this, he was like this real big, big man, like your typical like Greek person you would think about. It was really funny.
Okay.
And he got ran over by a car.
I can't taste anything. I think that's the worst part.
Oh, I hate that.
Like, I want to taste. Okay, where are we? Oh,
I should have watched that video first. It would have made more sense when I did this homework.
oh dear.
I should learn my lesson by now.
Yeah, doing the activity actually. Oops.
No, I mean, I did the activity, but I didn't watch the video. And I should have.
Yeah. I always watch the videos, if anything, because I feel like she works out problems pretty similar.
Yeah. Normally I do, but I didn't this time, and I should have.
You're in a row.
I feel like these problems have got to get more complicated. Because everything else has.
Homework has been so easy lately, though. It's been great.
Yes, this week has been super refreshing.
Like, so nice. You just get through it pretty quickly.
Yes. So what do we learn after limits?
The whys.
They said this is the what? This is in the Y section.
So interesting. Use the graph below to find delta curves. Value of delta.
Give me 1 second. I gotta go.
Okay, is delta like the part on either side of the number, or is it the combined?
It's the distance on either side of the number.
Okay.
I think it's silly that they went through all this trouble to make up all these symbols for the words, but then didn't make a symbol for when. So then we have to write when over and over and over.
Sorry, I had to get my kids' lunch started.
I think it's interesting that kids always think they should be allowed to eat.
I know. I told them we could save a lot of money if they would just stop. But my 11-year-old, doesn't matter what time of day she wakes up, she still has to have 3 meals, according to her. So even if she gets up at 10, she still has to have lunch and breakfast and dinner. I'm like, it's basically lunchtime at this point.
Funny.
My son has, I told him that if he gets up in the morning before me, he has to eat breakfast before he gets on the computer. So when I get up and he's on the computer, go in there and make breakfast for his sister, and not him. And he's and then one day he's like, I don't get this, making food for Ambria and not for me. And I'm like, you're on the computer. That means you've already had your breakfast. And you had your breakfast. That's on you. I'm like, you were supposed to eat breakfast before you got on. If I got on and I got up and you weren't on the computer, I would make you breakfast.
That's
but now
funny.
you know you've already had breakfast.
Have you done 4?
I was just about to.
So at the end it says, remember 3 minus x equals x minus 3. Why? Is it just because it's absolute value?
I don't know.
Are all of the homework problems created by our teacher?
I don't know.
I think the ones that say instructor created questions are the ones she made.
So all of the like pre things. The preps.
Okay, gotcha.
They might, but because there's more than one section,
Uh-huh.
it's possible she didn't create them.
It could have been whoever's in charge of whatever. So my kid's high school, the one she's going to, actually is requiring them to take a class called personal finance. I was like, yes, life skills.
I would like that.
Yeah, I'm super appreciative about that. She's like, they'll be ready to go out into the world when they leave here.
And grade number 2 on the homework, actually.
You should see some of my delta signs when I first started drawing them.
Sorry, I'm like coughing into this.
Oh, you're fine.
Given a function.
Wait a second. So, because, see, I factored out a -2, not just a 2 on number 4.
Mm-hmm.
Absolute value, is that why you dropped the negative?
I think so. Because I just factored out a regular 2. But that's why I was wondering is that why 3 minus x is the same as x minus 3?
Where does it say that?
In the actual answer key. It says, remember, absolute value of 3 minus x equals absolute value of x minus 3.
In the actual answer key?
Yeah, in the answer key for this.
So, but I'm looking at the answer key. Like the handwritten answers, right?
Yeah, let me pull it up. Hold on. Unless I dreamed it, because, that's a possibility.
Oh, there. I see it now.
Yeah, I was wondering if...
Yeah, I think it's because the absolute value means that it doesn't matter which one you subtract from the
which
other.
direction. It's still the same. Okay. Because I was like, what?
Because the distance between them is the same no matter which one you subtract.
That's true.
I shouldn't have stayed up till 2. I knew I had to take the test this morning.
Yuck.
I do a lot of stuff I shouldn't.
I think we all do.
Alrighty, well, did we finish? I think we're finished everything we needed to, right? Question, does she do test corrections for every test?
I don't know, but she said this one was.
This past one?
Yeah, you can correct for this one.
Oh my gosh, I need to do that.
Yeah, they do on Saturday.
Do you have to do that for?
Huh?
How long does she give you?
She didn't say. I'm assuming you still can do it.
I think it was Saturday night. I'll go look.
Up until Saturday night?
I think so. I'm gonna look at
This Saturday night or last Saturday night?
Yeah, this Saturday. Because she didn't give it to us till Monday. I know those corrections on the last test helped me get an A. I was like, yes.
Yeah.
Especially since the only reason I got most of them wrong is because I forgot to add the plus C. I'm like, really?
That sucks. Oh my gosh.
Yeah, really? I mean, I'm glad that she gives us partial credit because if it wasn't for that, I'd fail all of her tests.
Okay.
But I tried her on this last one. I didn't forget.
You must email your test corrections by Saturday night at midnight in order to be counted.
Yeah, so you're good.
I made stupid mistakes on the last test. Like when I was taking the integrals, I was multiplying by the derivatives instead of dividing by the derivative.
Oops.
Oh my. Oops. Because, you know, the inner function, like sine of 3x, I put 3 cosine of x, and 3 is cosine of 3x instead of cosine of 3x over 3.
So I missed problems I thought I got right, and then one of the word problems I literally looked at and said, I have no idea. I just started writing. And I was like, something's got to be right on this. I actually got the problem answer right.
Dude, yeah,
I was
like the whole last page, I thought I got that so wrong. Like, but then like all of it was right somehow.
Yeah, it was crazy. I was impressed. I was like, wow, I guess I do know a little bit more than I thought I did.
Whenever I'm confused by a question, I just start spewing everything I do.
Yeah. That's what I did. I just started spewing stuff, and apparently I got the right answer. Okay, she just said she was passing today.
What?
She decided not to come today. The only reason we scheduled for today.
Don't you get like marked off for not doing that?
Yeah. So she won't send in a link because she didn't do it.
Okay. Oh wow, I cannot wait to do these corrections. I'm gonna boost it so much.
Did you make stupid mistakes too?
I just like blanked on a lot of it. It's just there's so many rules. I just like forgot so many of them.
Oh, gotcha. I do that. I did that too. But then I just like spewed stuff.
I think we should, you know how we've been writing over and over? I think we should have been doing that with the integrals.
I agree.
Because
What?
I get confused.
Do what?
Write the integral rules over and over and over again.
I haven't had too much of a problem with them. For some reason, my brain's actually retaining it, which is amazing because it never retains anything. But I struggle with the word problems a lot.
Yes.
I don't know what's going on.
Sometimes the word problems, I look at them and I'm like, what are you even asking for?
I know. I'm like, wait, what?
Right. I'm like, I think that's English, but when I look at them, I'm like, ooh. When you put them together like that, that don't make any sense.
So we're done, right? We could probably stop the project.
I think so.
Yeah. Okay. Find the broadcast again.